Hello guys, let's continue our vectors video. In the previous video we learned what vector is, how we write vectors in component form, and what direction and magnitude is. Now let's talk about equal and parallel vectors. So in order to have equal vectors we should have same magnitude and same direction. So let's take a look at the given figure, vector u and vector v. They are parallel to each other. They have same magnitude and same direction. They are pointing in the same direction, see? And they have the same magnitude. How do you know if they have the same magnitude? First of all, if you can't find it out by eyes, you can just write it in component form and see if they are same. If you have the same component forms, same numbers inside of these sharp brackets, then they're equal. So for vector u, how many units you have to go to the right? 1, 2, 3, 4. 1, 2, 3, 4 units to the right. To go up, we should go 1 unit. So for 1 is vector u in sharp bracket. In vector v, 1, 2, 3, 4, 4x, 4y, 1 unit up. So 4, 1, 4, 1. You have exactly the same vectors. It means they have the same magnitude. Try to remember what magnitude is. Under radical, square root of x, square root of y. Since they have the same numbers, you'll get the same result. So their length, their magnitudes are same. And as you can see, the directions are also the same. Direction is about the angle. Remember, to find the angle, we were using trigonometric ratios. We were using tangent theta. Remember, opposite over adjacent. Opposite is 1, adjacent is 4. So 1 over 4 for both. So having the same vector written in the same component form means your vectors are equal. So you should have the same component forms to get an equal vectors. To get a parallel vectors, to get a parallel vector, you should either have the same direction or opposite direction. You don't have to have the both of them pointing to the same direction. You should have either same or opposite. About the magnitude, it is not necessarily saying anything about the magnitude. It doesn't matter what magnitudes are. One can be less than the other. One can be greater than. It doesn't matter. Okay, what matters is having same or opposite directions. So how do we figure out if two vectors are parallel? So again, we can write both of them in component form and see if the ratios, trigonometric ratios, are the same. So let's write vector x in component form. How many units you should go to the left to get to the terminal point? 2 units to the left. So it's negative 2 since you are moving in the negative x direction. And you go 1 unit up. So in a sharp bracket, negative 2, 1. So what is the ratio, trigonometric ratio? I mean tangent by trigonometric ratio. Because we are talking about direction. Direction means angle. Angle means trigonometric tangent ratio. Opposite over adjacent. Opposite is 1. Adjacent is negative 2. So the ratio is negative 1 over 2. So you should have the same ratio for both of the vectors to be parallel. What about vector w? For vector w, let's figure out how many units is the horizontal change. 1, 2, 3, 4 units. Where are you going? Right or left? You are moving in the right positive horizontal direction. So it is 4, positive 4, comma. What about vertical direction? Vertical change from initial to terminal 1 2 units. So you are moving down, so it is negative. Moving right, positive. Moving up, positive. Moving down, moving left gives you a negative answer. So negative 2. Again, we are talking about direction. Direction means angle. Angle means trigonometric ratio. By trigonometric ratio, we mean tangent. So let's uh, figure out what tangent of this angle is. It's opposite over adjacent. The opposite is the vertical change, which is negative 2. Adjacent is the horizontal change, which is 4. Simplify it. It is negative 1 over 2. So same ratio. So whenever you have the same ratio, which means vectors are parallel. All right? So can we also say that when you look at the first figure, did you realize that they also have the same ratio? See, 1 over 4, 1 over 4, they have the same ratio. So can we say that equal vectors are also parallel? No, so yes, of course, we have to say that equal vectors are parallel because they have the same trigonometric ratio for tangent ratio opposite over adjacent is the same for both of the vectors. So we can say that equal vectors, it's also written here, equal vectors are always parallel vectors. So whenever you are asked to find parallel vectors, you can always say that equals are parallel also. Let's take a look at an example. Let's take a look at a bunch of vectors and see if we can figure out if there are any vectors that are equal or parallel to each other. So check it out for part A. Identify equal vectors. So as we did in the previous two figures, let's write each vector in component form and see if we have same vectors or same ratios, one by one. So let's write them down. For Mn, write it in component form. Horizontal change is 2, it's going to the left, negative 2. Vertical change, 2, it's going down, so it's negative 2. For Mn, for PQ, a horizontal change, 1, 2, it's moving left, so negative 2. Vertical change, 1, 2, 3, it's moving down, so negative 3. RS, how many units? 2 units to the left, negative 2. 1, 2, 3 units down, negative 3. XY, 1, 2 units to the right, so positive 2. 1, 2 units up, positive 2. So now we're going to check if we have the same component forms for equal vectors. Do you see any same component forms? You have negative 2, negative 2, 2, 2, different. Negative 2, negative 3, negative 2, negative 3. Yes, those two are the same, exactly the same vectors. So we can say PQ, put an arrow on it, is equal to what else? RS. Vector PQ is equal to vector RS. They are exactly the same. They are written in the same component form. So if this vector has been displaced here, I consider them to be the same vectors, right? There is just a translation. You can shift RQ to or PQ to RS. You can translate this, shift this to the right in this way. You are gonna have the same vector, exactly the same vector. I cannot twist the vector. I cannot direct it. I cannot expand or shrink it. That's not allowed. Otherwise, just by translating it, I have an equal vector, okay? Just by translating a vector, I can have an equal vector. Okay, just these two are the equal vectors. What about parallels? As we mentioned before, equal vectors are always parallel. So for parallels, we can write those two vectors. PQ is parallel to RS. This indicates that those two are the parallel vectors. Are they the only ones, only parallel ones? We have to check. Remember, we have to check the ratios: horizontal vertical change over horizontal change, opposite over adjacent. Opposite is negative 2 here, adjacent is negative 2, negative 2 over negative 2, 1. The ratio of opposite over adjacent is 1. What about ratio here in these two vectors? Negative 3 over negative 2, which is 3 over 2. So those two are 3 over 2. We already wrote them as parallel vectors. What about the last one? 2 over 2. What's the ratio? Vertical change over horizontal change. 2 over 2, 1. So I have two ones here. The first vector and the last vectors, opposite over adjacent, the trigonometric ratios are the same. So they're also considered to be parallel to each other. So by just looking at it by eyes, we can also see that MN is parallel to XY. But to make sure you can do this, we have to make sure this by finding the ratios opposite over adjacent. So let's write them down. MN, vector MN is parallel to vector XY. So as you can see, MN is pointing in this direction, XY is pointing in that direction. They have the opposite directions, but it doesn't matter if they're opposite directions or the same directions. They can be parallel to each other. So we had a lot of questions about equal and parallel vectors in the book. We have exercise questions a lot. You can practice them. Those were how we figure out parallel and equal vectors. We have one more topic that I need to mention: resultant vector. Resultant vector. So to find the resultant vector, all we have to do is add two vectors. Let's say we are given 1, 2, comma, vector 3, 4. So all we have to do is add x's together and y's together to get the sum. So 1 plus 3 is 4, 2 plus 4 is 6. So this is how you find the resultant vector, by adding two vectors together, x components together, y components together, we get the sum. That's it.